Algebra 1, Lesson 56, we are looking at direct variation and being able to identify it, write direct variation, and be able to graph it as well. So with this, when we're talking about direct variation, these are equations that are in the form of y equals kx, where k doesn't equal 0. With this, k is our constant of variation, or constant of proportionality, which is the coefficient of x. Two things that we need for direct variation is it needs to pass through 0, and it's a line, and the equation can be written in the format of y equals kx. What we really have here is a straight line like we normally have. We normally have y equals mx plus b, but in this case our y-intercept is 0, so we have y equals mx plus 0, which is really just y equals mx. Well, these special type of equations, we say we have this formula y equals kx to remind ourselves that we have this constant k that we can work with. So when one value increases in direct variation, so does the other. As one value decreases, so does the other. Okay, they go in the same manner. So when we have all of these different equations, we can look at them on one graph and see that if we have k being 1/2, where we could enter it into the calculator being y equals 1/2 x, and y equals 3x, y equals negative 7x. Well, really what we're seeing here is the difference between these is just the slope. So if we have a higher number, like negative 7, it's a really steep slope, or 3 or 1/2 is a really small slope because it's a lower slope value, it's a lower constant. So is an equation a direct variation? Well, let's transform these to see what does y equal. And in this first case, I'm going to subtract 8x from each side to get y is equal to negative 8x. And yes, this is in the form of y equals kx, where k is equal to negative 8. This next one, we can do something similar and subtract 5x from each side to get y equals negative 5x plus 1. But because of that plus 1, this is just a line, but it's not a direct variation. Okay, let's try a couple more. In this case, y has been divided by a number, so I'm going to multiply by that number on each side. So I get y is equal to 7x, for sure direct variation, with k being 7. And same here, we get y equals 10x, so k is equal to 10. So, with these, to get y alone, I need to divide by x. And we get y is equal to 1. Unfortunately, this is not direct variation because if I plotted it, and we had one right here, this would actually be a line, a horizontal line that does not go through the origin. And this next one, if we divide by x, we get y is equal to 6 divided by x. This is not direct variation. This is actually inverse variation. And we would end up seeing something like this for inverse variation. Very, very different from our straight line through the origin. Next, let's figure out if we have direct variation between certain points. And the first thing we need to do is find the ratio for each pair. So we do y divided by x. This comes because if we have y equals kx, to find what the constant is, I'm going to have to divide by x. And we see that k is equal to y divided by x. So that's what we do here. We say 14 divided by 2, and negative 35 divided by 5, and 21 divided by negative 3. Those actually all come out to negative 7. So if all of those ratios end up the same, we say that this is direct variation. We could create our equation by saying y is equal to negative 7x. Okay, for this one, let's see if the ratio is the same. We have 4 divided by 2, 5 divided by 3, and 7 divided by 5. Unfortunately, those are not the same ratio, so no, this is not direct variation. Write an equation given a point. Well, with direct variation, we can just take our equation y equals kx and plug in x and y to find k. So we start with the function. We plug in y for x, and we solve for k, dividing by 4. we see that k is equal to -3/4, so our equation is y equals -3/4 x. So even just given 1 point, because we know that 0, 0 is a point, and this is our equation, we can easily find our equation. All right, another example, the distance a person runs varies directly with the time spent running. If a person runs 12 miles in 2 hours, how many miles will the person run in 3 hours? Well, we're actually given a point, 2, 12. So we can plug it into our equation, y equals kx, so that we can say 12 is equal to k times 2. So we divide by 2 and see that k is 6, so we have our equation y equals 6x. And then if we want to know 3 hours, we can say, well, x would then be 3, so we have 6 times 3, or 18. 18 miles. Okay, and we can do this for 100 miles, 1,000 miles, 1,000,000 miles. Let me just do a couple more examples here. All right, let's see if this ratio is the same. 12 divided by 3, 8 divided by 2, and 16 divided by 4. It looks like, yes, k is 4. And then we have 6 divided by 4, 3 divided by 2, and 36 divided by 24. Those are all equal to 3/2. So this is direct variation, with k being 3/2. And write an equation given the direct variation that includes the point 6, 24. So we say y is equal to kx. So 24 is equal to k times 6. Divide by 6 on each side and see that k is equal to 4. But we're not done because we need to write an equation, so we say y equals 4x. And the second one, same process, we get y is equal to 6x. Okay. A store sells 3 pounds of lemons for $1. Graph the relationship and then use the graph to estimate the cost of 12 pounds of lemons. Well, when we do this, we see that, okay, we have our points here. And I'm going to say, all right, 3 pounds of lemons is $1. Well, I also know that 0 pounds is $0. 6 pounds is $2. 9, let's see, 3, 4, 5, it should be right here. Sorry about that. Okay, we could keep going, but we see that for every 3 pounds, it's $1. Okay, so we have this 3, 1. We can plug that into an equation to say y equals kx, so 1 is equal to k times 3. So k would have to be 1/3. So if I have y equals 1/3 x, and I want to know for, well, x, 12 pounds of lemons, I would say y is equal to 1/3 times 12. So those 12 pounds of lemons would have to be $4. The number of boys in a class varies directly with the number of girls in a class. One class has 6 girls and 18 boys. Okay, and that's our point, 6, 18. So we have girls and we have boys. How many boys will be in a class with 8 girls? So let's find our equation. We have y equals kx, so 18 is equal to k times 6. So k would have to be 3. Meaning that for every girl, we have 3 boys. So y is equal to 3x. If we have 8 girls, that's our x value, so y is equal to 3 times 8. We have 24 boys. Okay. And then I believe, yep, this is our last one. The volume of a box with a fixed base area directly varies with its height. A box with a height of 4 centimeters has a volume of 29 centimeters cubed. Graph the relationship and then use the graph to estimate the volume of a box that is 3 centimeters tall. Well, when we do this, we would have our normal graph. I'm not going to show that on here, but we can plug in and find our equation and say 29 is equal to k times 4. We divide by 4 on each side and see that k is equal to, looks like 7.25, meaning for every centimeter, we have 7.25 of volume. So y is equal to 7.25 x, and we say, if I have a box that is 3 centimeters tall, I'm going to say 7.25 times 3. which means that we're going to get y is equal to 21.75 centimeters cubed. Well, I hope this is helpful for your homework and for studying.